Hey everyone, hope you guys are doing well today. So today we are going to talk about the mean value theorem, and I'm going to give you a problem and walk you through it, and hopefully that will show you how it's used and why it's useful. So let's say you have a problem that says a car moves in a straight line. At time t, its position is given by the function s of t equals 1 over 25 times t cubed, for 0 is less than or equal to t is less than or equal to 10. So if you remember, the mean value theorem states, so let's see, mean value theorem states that if f of x is continuous and differentiable, that f of b minus f of a over b minus a is equal to f prime of c. Okay, so let's start out with the left-hand side of that. What does that even stand for? That actually stands for the slope of the secant line. So if we go back to my graph here, this is just a rough drawing of the function that I did, this dotted red line is the secant line. And if you remember, the slope of that is actually going to give you the average velocity of, in this case, the average velocity of the car. So average velocity. So then going back to our mean value theorem, on the right-hand side, we have equals f prime of c. So going back to our graph, this orange line here is the tangent line, and this is going to give us the instantaneous velocity at time c. So what we can say using the mean value theorem is that the slope of the secant line, or the average velocity, is going to equal the instantaneous velocity at some time. So what that means is that, let's say you're in the car and you start out at 0 and then you go to 100 miles per hour and then you go back down to 2 miles per hour and then you go up to 7 miles per hour at all your different times. All we can say with the mean value theorem is that if your average is 4 miles per hour, at some point you are going to have to be going 4 miles per hour. So the slope of the secant line, your average, which is 4, has to equal your instantaneous velocity of 4 at some point in time. So you can't ever just skip over your average velocity during your instantaneous velocities. So plugging this in, let's see, I already did this earlier, that's how I knew it was 4, but I will go ahead and demonstrate. So if we have, let's see, so we do s of 10 minus s of 0, I'm just plugging these values in using the formula, over 10 minus 0, this is going to equal f prime of c. So s of 10 is going to be 40, I did that earlier, and then s of 0 is going to be 0, over 10 minus 0, simplifying this, we get 4. So what that means is, as I said earlier, the instantaneous velocity at some point in your trip, so at some time between 0 is less than or equal to t is less than or equal to 10, you are going to have an instantaneous velocity of 4 miles per hour. And that's one application of the mean value theorem. Sometimes I like to think of it, instead of like mean value theorem, I like to think of it as an average value theorem, because it's saying that the rate of change at a time is equal to the average. So hopefully that helps. I'm also a math tutor. If you have any questions, I will leave my email in the description below, and I offer Skype tutoring if you're interested. Thanks for watching. Have a nice day.